Sample problem 23.07. Figure shows portion of two large parallel non-conducting sheets, each with fixed uniform charge on one side. The magnitudes of the surface charge density are sigma plus, which is equal to 6.8 microcoulomb per meter square for the positively charged sheet, and sigma minus, which is equal to 4.3 microcoulomb per meter square for the negatively charged sheet. Find the electric field to the left of the sheets, between the sheets, and to the right of the sheets. So in this question, we are going to calculate the electric field in three places. What are the three places? You can see the given figure. We have two non-conducting sheets with the surface charge density value, and one plate have the positively surface charge density value as 6.8 microcoulomb per meter square, and the next plate, that means the second plate, which has the negative charge distribution, which is the surface charge density value is 4.3 microcoulomb per meter square. Now what we are going to do, we are going to find what is the electric field left side of the sheet. That means this is our first location, which is left side of the sheets, and the second location is between the sheets, and the third location is right side of the sheets. Clear? Okay. Now we have to use the formula, because in theory 23, chapter 23, we studied the formula for non-conducting sheet, which is E vector equal to sigma over 2 epsilon naught. So we have to use this formula for this question. So first of all, let's find the direction of the electric field. That's very, very important. So let's consider, because we are going to find the electric field at this point. So let's make a point here, midpoint, and this is the right side. Of the electric field by the positive charge. So if you consider this location is near to this positive charge. So your field lines are directing outward direction. Clear? Because the positive charge, the field lines are going outward direction. And in this point, with reference to this point, we have to find what is the field lines of the negatively charged plate. So negative charge field lines are inward direction, but here the distance is matter, and this point is far away from the second plate, but you have the field strength, but weak strength will be there. So the field lines based on the second charge plate is pointing towards the plate. Clear? Because negative charge, the field lines are inward. And when we come to the second location, based on the positive charge, the field lines are outward direction, right? Based on the negative charge, the field lines are inward direction. So now you can see both lines are exactly the same direction. So how it is same direction? The positive charge, the field lines are outward direction. In negative charge, the field lines are inward direction. Clear? Because the positive charge, from the positive, the field lines going outward. But for the negative charge, the field lines are inward. That's the reason two arrows are in the same direction. Now we have to come for the third location. Based on this location, we have to see the positive charge, and the positive charge value is the greater, 6.8 microcoulomb per meter square. So what will happen? Your field lines will be outward direction, and then for the negative charge, the field lines are inward direction. Clear? Now you can see the location 1 and 3, you will get the same answer, only the sign will differ. Clear? But in the midpoint, you will get the greater value. Why? Because both lines are going in the same direction, so the value will be greater. So now what I'm going to do, I'm going to use this formula for each line. So let's start with the first one. So for sigma plus, because this is for sigma plus, this is for sigma minus. So if you consider for the first question, sigma plus, which is equal to, sorry, not sigma, I just made a mistake, I'm extremely sorry. So this is electric field, right? So electric field for the plate. So this is also electric field. So electric field, which is equal to surface charge density for the first plate over 2 epsilon naught, and then we have to subtract because both are opposite direction, and here this arrow is moving to the left direction, so I have to put negative sign, but this arrow is moving to the positive direction, plus sigma minus over 2 epsilon naught. Now I'm going to substitute the value. So what's the value for sigma? Plus 6.8 microcoulomb, and this one is 4.3. So let's substitute the value. If you substitute the value here, what you'll get? Sigma plus value is 6.8. 6.8 multiplied 10 power minus 6 over 2 multiplied by constant value of epsilon naught is 8.85 multiplied 10 power minus 12 plus, and this is minus, right? And then sigma minus is 4.3 multiplied 10 to the power of minus 6 over 2 multiply 8.85 multiply 10 to the power of minus 12. So let's see what is the answer. Minus 6.8 10 to the power of minus 6 over 2 multiplied by 8.85 10 to the power of minus 12 plus 4.3 10 to the power of minus 6 over 2 multiplied 8.85 10 to the power of minus 12. So here I got the answer as the electric field is pointing to the negative direction. So negative of 1.41 multiply 10 to the power of 5, and the unit is Newton per coulomb. Clear? And now we have to come for, this is for the first location, location 1. And second question, we are going to find the electric field for the between the sheets. That means the second location, both arrows are pointing towards the same direction. Am I right? So we have to use the same formula for the positive as well as this negative. So electric field, which is equal to sigma over 2 epsilon naught plus sigma over 2 epsilon naught, which is equal to 2 sigma over 2 epsilon naught. So it will be get cancelled. So here the sigma, sorry, better we can substitute separately because both sigma are different. So this is for positive value, this is for negative value. So let's substitute the value. 6.8 multiply 10 power minus 6 over 2 multiply 8.85 multiply 10 to the power of minus 12 plus sigma minus is 4.3 multiply 10 to the power of minus 6 over 2 multiply Newton per coulomb. So this is for between the plates. So this is the left side of the plate. This is between the plates. Okay. Now we have to come for the third location. So the positive will be in the right direction and the negative in the left direction. So for the right side of the plate, which is your third part, which is your third location, electric field, which is equal to sigma plus over 2 epsilon naught is in the positive direction minus sigma minus over 2 epsilon. Why I put minus here? We have to see the figure. You can see the figure here. this is for sigma plus, this is for sigma minus. So this points towards the negative direction. That's the reason I put negative sign. Clear? So now I'm going to substitute the value. 6.8 multiplied 10 power minus 6 over 2 multiplied by 8.85 multiplied 10 to the power of minus 12 minus 4.3 multiplied 10 to the power of minus 6 over 2 multiply 8.85 multiply 10 to the power of minus 12. Here we will get the same answer as a part but positive sign. So 1.41 multiply 10 to the power of 5. 1.41 multiply 10 to the power of 5 Newton per Coulomb. So this is the electric field for the right side. Clear? So the answer for A and C, same answer but sign differ. For the first part, you'll get negative value. For the third part, you'll get positive value. Clear? So this is the answer for this question. That's it. Thank you.